All right, so on Monday we talked about the surface area of pyramid or prisms and cylinders, and today you're going to see we have very similar formulas. It's only slightly going to be different because we're dealing with pyramids and cones. I hate to really make an observation that's this obvious, but what's the difference between a prism and a pyramid?
One has sides.
They both have sides. I mean, this is like a ridiculously simple question.
Different
Maria?
words.
Pyramids, like the one shape that goes as a side to the base.
Kind of.
Cones are circular.
What's the difference between a cone and a cylinder? Jackson?
Well, if you think about it, they're like a pyramid has one less side than prism, and the cone has one less side than a cylinder
Why does it have one less side?
because it comes to a point instead of
Ah. There we go. That's the difference. That's the only difference. A pyramid and a cone come to a single point. That single point is called a vertex. And that's really what separates pyramids and cones from the others. Pyramids and cones come to a point. And a cone is just a special pyramid. It's a pyramid with what shape as the base? A circle. So the formulas for a pyramid are going to be exactly the same as those for a cone, only they look different because they're adapted for the circular base. But it's the same exact formulas. Now, two things we're going to add to this list today are slant height. We've already somewhat talked about height. What does it mean to be slanted?
At an angle.
At an angle, right? Leaning at an angle would be at a slant. So we're talking about slant height. What we're really talking about here is the distance from the vertex to the side. And you're kind of going along the face of the pyramid, and that's your slant height. When we look at a cone, the slant height, which is represented by the letter L, is literally the side of the cone. By the way, when you have a cone, what type of a triangle do you have?
Isosceles.
Some isosceles triangle. Alright, so if you guys are ever like trying to figure out how to draw your cone, it's really easy. You basically draw an isosceles triangle and then draw an ellipse at the bottom. And then you're done. Alright, so those are your slant heights. Now the height is literally like dropping a line directly from the top of the cone or pyramid directly down to the base. And that's going to be your height. It's the inside height. And if I draw a line from my height to where it connects with my slant height, what type of triangle did I just create? Created a right triangle. And that's going to be really important when we make that connection, that the height and slant height are related because together they form a right triangle. And we're going to be using that a lot today. All right, who can remind me what lateral area is? What is lateral area? Think back to Monday. We talked about lateral area and total surface area. What was the lateral area? Just what is it? I don't want the formula. Just tell me what is it? What does it represent?
The area
Area of what?
of
Not the whole thing. That's total surface area. Area of the sides. Okay. On a pyramid, what shape are my sides? They're triangles. How do you find the area of a triangle? Look at your sheets. Math. How do you find the area of a triangle? Half base times height, right? Okay, so let me ask you this. Let's suppose this is my side 1. This is side 2. And then we have side 3 in the back, side 4. How many triangles do I have then? I have 4 triangles, right? And you guys told me, let's kind of add down here. So let's go ahead and draw my little triangle. And what was this length right down here? On that triangle, what is that length? What do we call that? Yeah, what does the L represent?
Right, or side height.
Slant height. Okay, and this whole thing right here is my side, right? So therefore the area of each one of those triangles is 1/2 the base, which is the side, times the slant height, right? And then if I add up all those triangles, what I end up with is area equals 1/2 side 1 plus side 2 plus side 3 plus side 4, and that could just go on and on times L. What is this? Side 1 plus side 2 plus side 3 plus side 4. If I take all those and I add them up, what does that actually give me? No, just think about one piece at a time. If I take my side 1, I add my side 2. Nick?
The perimeter of the base.
It gives me the perimeter of the base. And so when we talk about pyramids, we're talking about the lateral area of the pyramids. The formula is a little weird. It's 1/2 PL. 1/2 perimeter of the base times the side. 1/2 PL. No, no. Slant.
It's going to be the vertex. It's going to go along the center of the face. So these are not your slant heights. That's your slant height.
All right, now on a cone, we're going to adapt the perimeter because we have a circular base. And when we're all said and done, we're left with pi RL for a cone. So you might be looking at your formula sheet and thinking, okay, where does that pi RL come from for cones? And that's basically where it's at. It's basically that you take 2 pi r, and if you take half of 2 pi r, you're left with 1 pi r. So we have pi RL. All right, any questions so far over any of the variables we've talked about or the formulas themselves before we start applying things?
So R is radius and L is length.
R is the radius, L is slant height. So R is your radius, L is your slant height. Okay, so now that was lateral area. What's missing from lateral area? Area of the base. So for pyramids, it's really easy. It's 1/2 PL plus B. And for a cone, not that big of a deal. I only got 11 going from Windows to PC. It's pi RL plus pi R squared. Perimeter of the base. Okay, so let's take a look at number 1. What do you ask to find on number 1?
Lateral area.
Just the lateral area. What shape do we have?